Hi there. This video series is to display my problem solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm vocalizing my thoughts while solving the 43rd Project Euler problem. As always, I will link to Project Euler and my repo in the description. Let's dive in. Problem 43 is substring divisibility. The number that is a 0 to 9 pan-digital number because it is made up of each of the digits 0 to 9 in some order, but it also has a rather interesting substring divisibility property. Let d of 1 be the first digit, d2 be the second digit, and so on. In this way, we note the following. Starting at d2, 3 digits is divisible by 2. The next 3 digits are divisible by 3, next 3 divisible by 5, and so on. So, in other words, we subdivide starting at d2, which is the second digit, so we kind of ignore the first one, and then starting with the second digit, we look at the next 3, and then the third, look at the next 3, and the fourth, look at the next 3. And also we look at, the first was the 6 prime numbers, 7 prime numbers, and each starting with the digit, those 3 numbers are divisible by those primes. So find the sum of all 0 to 9 pan-digital numbers with this property. Yeah, I'm going to do again that thing where I just copy all of this. Because, yeah. Okay. So I believe we were working with pan-digitals just the other day. Yep. I'm going to go back to here and grab these 2 lines. Okay. I think instead of this in pan-digital stuff, let's see. So first, find all 10-digit pan-digitals. Then go through each and save in a list if they have the divisibility. I spelled that wrong. Finally, print the sum of that list. Okay. So, how do we find all 10-digit pan-digital numbers? Here's what I'm going to do, is I'm going to make a digits equal to a list of 0, 1, 2, all the digits. Okay. And then what we want to do is there's a method in Python that allows you to get permutations. And as you may expect, it is literally called permutation. So we're going to do something like this. Not there. We want to put it up here. And this doesn't want to quite be what we want. We're going to need to do a little bit more to make this list what we want it to be. But let's go ahead and print out our pandigitals real quick. Or I'm going to print out just the first 5 so that we aren't completely overwhelmed. Okay, so as you can see, we got, we have our list, but this is all in, this is a list of tuples, actually. So I'm going to say pandigital join pandigital for pandigital in. And that should give me closer to what I want. Okay, so now we can see we have them as single strings, which is what I want. And I'm just going to do a real quick experiment here, where if I say pandigitals.0, 5, it gives me those 4 digits. Excellent. That'll be important later, I think. And then for first we have to make our list. Probably not the greatest list name in the world, but we'll go with it. So for every pandigital in pandigitals, we want to say, I'm going to go ahead and make primes, which is 2, 3, not 4. Prime in primes. Let's see. There's a better way to do this. And I'm going to say for I in range 2 to 9. And the reason I'm saying 2 to 9 is, again, because 9 is going to be exclusive, and I'm basically saying starting at index... Oh, it's actually 1 through 8. because of zero indexing. I'm just going to jump down and do this print. For I in range 1 through 8. I want to do the int version of pan digital from I to I plus 3 mod primes I minus 1 equals 0, then pan digitals with property dot append pan digital. Again, my variable naming is maybe not great. But basically we find all of our pan digitals. That way we don't have to go through tons of numbers and look for them. This actually would have been a lot better of a plan the other day when we were trying to go through and find this prime pan digital. Would have probably saved us a lot of time and been able to make it a little better of an algorithm. And then digitals, we make this empty list. We make a list of all of our 7 primes. We make a range of 7. And then we take this pan digital, which is a string, and we say we want the elements from index Control Z. Okay, it added the spacing automatically. Cool, that's fine. We take the index starting at, in this case, 1. Like, for the first loop, it would be 1. 1 plus 3 is 4, so it'll effectively be the same as this, going back to our problem statement, 2, 3, 4. So 406 for this number. And we actually made a bit of a mistake here, which is we're basically only dividing by the 2. That's not what we want. So we want to set has property equals to true. And we're going to say not equal to 0. Has property equal false. And this needs to be moved outside of this. And then this becomes a break. And then this, we move back over here. Okay, so that, if I am correct in my thinking, is just going to give us the correct answer. Let's see how long it takes. Okay, it did not. List index out of range. I am confused. Range is 1. I minus 1. Let's do a print added. so we can kind of see if we got anywhere with this. Okay, so maybe not. Maybe it's the absolute first time going through. Do you see the mistake? I didn't add the 17. So, that makes sense. We're going to delete that. Okay. Let's do another list comprehension. Or actually, instead of doing list comprehension there, let's just convert it to an integer here. That makes more sense, doesn't it? I mean, maybe not. I don't know. Okay, so we got this number. Let's go see if it is the correct number. And it is. There we go. And we did reach that in about 4 seconds. So I think we're very, very much done with this one. There's probably some refactoring opportunities here. For instance, like, I use kind of a list comprehension. Like, I'm doing a bunch of stuff in single lines here. Like, here, here, and a little bit here, although that one's much more simple. But it works quickly. I think it doesn't make sense to refactor it into a different algorithm, maybe just refactoring into some cleaner code. So yeah, that's all for today, and I'll catch you in the next one.